Hey guys, this is video part 2 for exponent rules. This one's going to be quite a bit more intense than the first one. And then the end of it, we'll pull everything together. We'll take all of our rules and pull them together as we look at some examples from homework for the next 2 nights. So if you've got your notes through your Teams page, we can go through the problems. If you're just going to write them down as the video goes, and you can fill it in as we show it here. So if we go back into our notes, the first topic we're going to cover here is going to be the idea of power of zero. So last week we talked about what happens when we are multiplying with the same base, what happens when we have exponents inside and outside. And if you remember, we talked about exponents. Exponents are an instruction. So remember that it's an instruction. The power of zero is an instruction, and anything to the zero power equals 1. And again, I'll say that anything to the zero power equals 1, except for 0. And we're going to talk about why anything to the zero power equals 1 a little bit later. And once we talk about that, you'll understand why 0 to the zero power is not something that'll work. So just remember, anything to the zero power is 1. We're going to take a look at some examples and some little nuances to how that can be different. But first example, 7 to the zero power equals 1. Don't overthink it. Don't worry about why it's 1. We're going to talk about that later. Right now, just trust me. X to the zero power equals 1. Now, there's a little exception to this. X can't equal 0. And the way we would write that is that X cannot equal 0, because 0 to the zero power you can't do. -8 in parentheses to the zero power. That means the 0 applies to the 8 and to the negative, so that equals 1. Now, -8 not in parentheses to the zero power will equal -1. The 0 belongs to the 8, and then the negative sign, if you remember, just goes along and attaches after. All right, let's zoom out here a little bit. 0 to the zero power, that is going to equal undefined. Can't have 0 to the zero power. So the first idea, the first rule, anything to the zero power equals 1, all right, unless it's 0. Remember that. That's going to come up as we work through this section. Okay, now, negative exponents. Negative exponents. This is the big idea that we're going to add. Negative exponents is an instruction, and it is an instruction to send to the other side of the fraction and then make positive. A negative exponent basically means to flip a reciprocal of whatever has that negative exponent. Okay, so remember, exponents are an instruction. And the instruction of a negative exponent is to flip it. And once you have flipped it, then that exponent becomes positive and you'll use it. So if I have this first example, we'll just go ahead and bring up both these examples then. 3 to the -3rd power. So the negative sign tells me that I need to flip this as a fraction. Well, 3 is a whole number. So if I flip it to a fraction, that becomes 1 over 3 to the 3rd power. So notice the 3 to the -3rd gets flipped to the bottom of a fraction. And once I send it to the fraction, the exponent then goes from negative to positive because I did what the instruction wanted me to do, which was to flip it. Now I'll just evaluate it. So 1 over 3 to the 3rd is 1 over 27. So if you have a regular whole number with a negative exponent, it's going to become a fraction. It's going to become smaller. Now, what if the piece that I have with a negative exponent is already in the bottom of a fraction? Well, that's what we have here. So we have 8 over x to the negative fifth. Well, the negative exponent means I have to flip it. So in this case, I have to send it back to the top. Well, the 8 is already here. It's already above. It doesn't have any exponents, so it's not going to do anything except just be 8. The x to the negative fifth is going to now go to the top of a fraction with it. And when I move it to the top, it becomes a positive. So now the fraction is essentially gone because the x to the negative fifth went to the top. All right. Let's take a look at 2 more examples. And these are examples that have negative numbers. A negative number does not matter at all in this situation. The only thing that matters is the instruction. And this little guy right here is an instruction that this whole thing is going to have to get flipped to the bottom of a fraction. Well, there is no fraction yet. So when I turn it into a fraction, notice the negative 4, the base doesn't change. The only thing that will change is the exponent. So when I flip the negative 4 to the bottom of the fraction, the exponent now becomes positive. And now just evaluate it. So 1 over a negative times a negative times a negative. That's 3 negatives. So this one's going to be a negative. And then 4 times 4 is 16. And 16 times 4 is 64. What about this other problem here? Negative 7. Coefficient is negative. We don't care. X to the negative fifth, y to the third. Only this guy has a negative exponent. So only that one will flip to the bottom. So when I have multiple pieces, what I like to do is I like to make the fraction bar and then decide what's moving and what's staying. Well, the negative 7 is going to stay on top. The x to the negative fifth has to flip to the bottom. And when it flips to the bottom, the exponent is now positive. And the y to the third is already positive, so it's not going anywhere. It stays on top. So the negative 7 and the y to the third stayed on top, and the x to the fifth went to the bottom. All right, so negative exponents. Let me give you one more example here. Let's go negative 5, x to the fourth, y to the negative third, z to the negative seventh. So think about what's going to move to the bottom of a fraction and what's going to stay. So let's make our fraction bar. Whatever stays, put on the top of the fraction. Whatever goes to the bottom, move to the bottom. All right, let's see what you got. The coefficient of negative 5, just because it's negative, I don't care because that's just the regular number. So negative 5 stays on top. X to the fourth is a positive exponent, so it doesn't go anywhere either. It stays on top. Y to the negative third is a negative exponent, so it goes to the bottom and becomes a positive exponent. And the z to the negative seventh also goes to the bottom and becomes a positive exponent. All right. So power of 0 followed by negative exponents. And now let's talk about the last idea and then mixing them all together. Fractions with exponents. A fraction means division. Remember, when we multiplied the same base, we added the exponents. Well, if we have a fraction or we have division with exponents, when dividing with the same base, you will subtract the exponents. And I'm going to show you a couple things here that are really key and important to understand because it will really help you as we go on. So we are going to subtract exponents. Now, there is two ways that we're going to look at this. The first is simply just subtract the exponents when we have the same base. So same base in a fraction, this will become 8 to the 8 minus 4 power. So remember, before when we multiplied with the same base, we added the exponents. Now I will subtract the exponents. And so that is then going to be x to the 4th power. Now, if I go to this example here, y to the 3rd over y to the 6th will be 3 minus 6. And so then that equals y to the negative 3rd power. Well, now here's the key, because typically you shouldn't leave an answer with negative exponents. So now we have to say, okay, well, what do we do with a negative exponent? We just learned what to do. We flip that to the bottom. So this is going to go to the bottom. And so now this becomes 1 over y to the 3rd. And this now brings me to the big thing that I think is the idea behind this. If you remember, we expanded things out before. Well, x to the 8th on the top of my fraction over x to the 4th. And if you recall, when we have the same thing on the top and the bottom of a fraction, we can reduce. So when I look at this and I expand everything out, the x's are going to reduce on the top and the bottom. Well, where do I have x's now left over? I have 4 x's left over. And where are they left over? They're left over on the top, which is where this x to the 4th power answer we got comes from. And if you look at the 8 and the 4, you're like, hey, I can subtract those, and I know I have more on the top. Well, let's look at it in terms of this second fraction, y times y times y over and in this one, the y's reduce away. And if you recall from reducing fractions in earlier grades, if everything reduces away, you're simply left with a 1. So everything is gone on the top, and I have 3 of them left over on the bottom, which is where I get this answer right here. There's the 1 left over on the top because everything reduced away, and there's a y to the 3rd because there were 3 left over. And if we come back to here, I had 3 of them on top, 6 of them on the bottom. So when I subtract them, I'm going to have the extras on the bottom. So this is going to be kind of that last big idea. So let's take a look at some more complex examples of what we're going to do when we have variables, or excuse me, a base that has variables and exponents. So the first thing is if there's just regular numbers in front, always reduce. So if you look here and here, the 4s reduce away. Okay, and those just become 1s. And then I have g to the 2nd and g. Well, remember, g to the 2nd means g over g, or excuse me, g times g. And then I've got 1 on the bottom. So those cancel out. So if I was to expand everything, I would have 4 times g over 4 times g. So again, if we just expanded everything out, well, the 4s reduce, the g's reduce, and the only thing left is the letter g. Okay. So let's take a look at this second example here where things are kind of messy. Especially when they're messy like this, one of the things I like to do is make my fraction bar and then fill things in as we go. So let's simply start with the numbers. If I ignore everything else in this problem and just look at those numbers, can 24 over 8 reduce? And the answer to that is yes. this becomes 3 and a 1. So that reduces to 3 over 1. And now let's look at the x's. I have an x squared and an x to the third. So ask yourself, where do I have more x's? Well, I'm going to have 2 of them on top and 3 of them on the bottom. So when they cancel out, where do I have extras? I have 1 x left over on the bottom. So I'm going to put my x on the bottom. And if I then look at the y's, say, okay, where do I have extra y's? I have 3 of them on top, 5 of them on the bottom. So if I was to expand them all out, I would have a y squared left on the bottom because there will be 2 of them left over. Well, I don't really need the 1 as the coefficient in front, so the final answer would be 3 over xy squared. So let's take a look at another example here of what that will look like for ones that are going to be a little bit messier. So let's go 4 x y over 8x squared y to the third. This is a good one here because everything will reduce away. So let's start with the 4 and the 8. They reduce down to 1/2. X to the first and x to the second. Well, I have extras on the bottom, so it's going to be an x squared on the bottom. And then a y to the first and a y to the third. I'm going to have extra y's on the bottom, and it's going to be y squared on the bottom. And then that would be your final answer when it's all simplified. So power of 0, negative exponents, and then what do we do when they're in a fraction? So that's the first part of this lesson. Now, the second part of this lesson here is going to take a look at homework problems. And so you're going to have some homework assignments that are already pre-made, and we're going to look at how do we look at each problem, and every problem has its own unique sort of rules here. So I'm just going to pull out a series of problems, and you're going to really need to break it down into little parts for some of the more complex ones. And so I'll jump around here for the assignments, and I'll just do various problems that you can then fill in afterwards. So I have a problem like this, 3 over x, all in parentheses to the 4th power. Well, remember that. That 4 that's on the outside belongs to everything that's on the inside. So this is going to become 3 to the 4th over x to the 4th. It belongs to both of them. That's the exponents inside and outside. So remember that 4 belongs to both. Well, 3 to the 4th power means that this is 81 over x to the 4th power. Take the exponent on the outside, send it in. All right. Well, what if I have a problem that looks like this? X to the 3rd times 1 over x to the 2nd. Well, remember, anytime I have a number like this, I'm going to put it over 1. I'm just going to multiply across the top and the bottom. So this becomes x to the 3rd over x to the 2nd. And now where do I have extras? I have 1x left over on the top. So x to the 1st power, or x. All right, let's jump down to another one here. A to the 9th power over a to the 5th power, all raised to the -1. One of the things I would recommend is that if you can clean up what's inside the parentheses first, do that before you use the exponent on the outside. It's like PEMDAS. I can clean up what's inside the parentheses before applying the -1. So I'm simply going to look at this stuff here. I have a to the 9th on the top and a to the 5th on the bottom. Well, I'm going to have in the parentheses still a to the 4th power, because I'm going to have 4 of them left over on the top and nothing left over on the bottom, with a -1 on the outside. So this is now a power of a power. So I'm going to take that -1 on the outside and I'm going to send it in. So that makes this now a to the -4th power. Exponents inside and outside multiply. Well, let's do one last step. The negative exponent is an instruction to send that down. So this is 1 over a to the 4th power. Let's jump ahead here to another one. -6x squared y all over 2xy to the 3rd, all raised to the 3rd. Again, let's clean up the inside first. So let's reduce what's inside here first. So let me write my fraction bar. I'm going to put this 3 on the outside, and let's just start cleaning this up and reducing. Let's take the numbers in front, the coefficients. -6 over 2 gives me -3 and a 1. I have an x squared on the top and an x on the bottom, so that means I'm going to have 1x left over on the top. And y over y to the 3rd, I'm going to have extras on the bottom, and I'm going to have a y squared extra on the bottom. Well, let's take this 3 now and send it into everything. Everything gets the exponent. So -3 to the 3rd power. And technically that should be in a parenthesis because that belonged to the negative sign as well. X to the 3rd power. All over 1 to the 3rd power. And y to the 6th power. Remember, exponent inside and outside. Don't really need these big x or parentheses on the outside anymore. Now let's just go ahead and do -3 to the 3rd. So -3 times -3 times -3 is going to be a -27x to the 3rd. 1 to the 3rd is 1 times 1 times 1. So that's 1. And then y to the 6th. Little details are going to be the key as we work our way through all of these exponents. All right, and let's do one real messy one here from the homework. Let's go over here. 4x, y over 2x to the -1, y to the -3, all raised to the 2nd. So we need to not only reduce, but we also need to get rid of negative exponents. And so what I would do at this point is I would get rid of negative exponents and then worry about all of the reducing that might happen. So we've got 2 things with the negative exponent. So that means this is going to have to move up, and that one's going to have to move up. Nothing else is moving because nothing else has a negative exponent. So I don't want to do too much at once. So I'm just going to just move the things that need moving. The 4 is going to stay. The x and the y are going to stay. on the bottom. The 2 is going to stay. But both of these are now going to move to the top. So now on the top, I'm going to add another x to the first and a y to the third. I just took both of these right here and I just moved them up. Didn't do anything except move the negative exponents. Well, now I have same base. So x to the first and x to the first means now on the top, I have 4x to the second. And I also have another same base. I have a y to the first and a y to the third. So that makes y to the fourth all over 2. And I still have that 2 on the outside. Let's reduce the 4 and the 2. So this becomes 2x squared y to the fourth over, and that's going to be a 1. Well, that's cool because that means everything on the bottom is now gone. And I have to now take the 2 that's on the outside and send it in. Well, 2 squared becomes 4. X squared raised to the second means 2 times 2, so that's x to the fourth. And then y to the fourth raised to the second means I got to multiply the 4 and the 2, so that becomes y to the 8th. We're going to have problems that obviously get more complex than this as well, but this at least takes us through a good chunk of assignment number 3. And at this point, you really just need to start working through some of them, troubleshooting where it is you're getting stuck, and then checking your work, because I'm going to provide answers for all of these for you guys to be able to check. That obviously is pretty loaded. There's a lot going on here. So take your time, work through it, and be sure to ask questions. If you have to come in on the work days, absolutely come in on those work days. All right. Hopefully this works for you guys. You might need to go back and look at it again, especially if you need to rewatch a particular problem to see where certain pieces came from. Have a great day, guys, and I will see you later.